So welcome back to Algebra 1. Just to go over a few quick logistics, which I'm sure you already know because you're already smart, already crushing it in Algebra 1. Look at you. You can always email me with questions for anything that's related to this course, technical difficulties, questions on material, anything about due dates. You can always email me here at ccortez@cohs.com. I always want to make that known. I'm always available. And for this section, we'll be looking at a few logistics before we start to really move into the algebra material, go beyond basics that I think everyone's familiar with, but hopefully everybody was able to polish those skills before we move forward. So this one section, dealing with combining like terms, I think is really important. This does not go away. And I'll repeat this again. Combining like terms does not go away. If you have any questions, please email me about anything that we see here. So in an algebraic expression, let's fill this in together, a monomial, think of mono as only one term. So something like 3x squared is a monomial because we have a number, seen here, 3 is considered our number. We have a variable, which is a letter, considered x in this case. And in addition to that, this may be a product of a number and one or more variables. So this is considered a monomial because there's a coefficient, there's a variable, and there's an exponent. But what's cool is that 3x is also considered a monomial. Negative 4y is also considered a monomial. And occasionally, for some reason, the variable goes away. So if this happens, we refer to that as a constant. It's a constant upset when there's a term that has no variable. So for something where you just see 7 on its own, what a shame. If you see negative 4 on its own in a problem, what a shame. No variable. That's just a shame. It's still a constant, though. It's a constant shame. You can think of it like that. In addition to that, we say that a coefficient is a numerical factor of a term. So, for example, 3x squared. Let's break this down. So 3 is a factor of this term. So 3 is multiplying with some variable. So we would say that 3 is our coefficient. Think of this like a commander. The commander leads everything. So that's why the commander's in the front. We then follow this up with a variable and an exponent. Sometimes these are visible, sometimes we have to improvise based off of a fact that we'll see in the next part. So you may want to pause this, take all the notes, write down everything. This material does come back again. So I want to make sure everybody gets this. So in addition to that, we say that if we are dealing with like terms or common terms, these have the same variable factors. So what does that mean? It means that they have the same variable. So the same variable, occasionally variables, and also the same exponents. So we would be able to declare that 7a and negative 3a, well, what do you think? Do these have the same variable? Do they have the same exponent? Hopefully we can agree that a is the variable. The exponent, however, we don't necessarily see that, but this is a really important fact, and I'll highlight this in a moment. If a variable has no exponent, consider it a 1. So although for these a terms, we don't necessarily see an exponent, there is a 1 here. but there's no need to write it because it's not multiplying by itself more than one time. So we just leave it as is. We see that 4x squared and 12x squared are the same because they have the same exponent, same variable. We do not see like terms here because although they both share a, they do not share b. B is on its own here. So we would say that for this example, these are unfortunately not like terms. That's really important to know because you can spot them, but it's important to also know when they're not like terms. And although with this example here, we see both terms have x here and here, both terms have y here and here, but are these still like terms? Does each variable have the same variable as the other term? You should be saying no. So notice that y is being squared, but x is being squared here. Y is different than the other y. So we would say that in addition, these are not like terms because the exponents are different. It's really important to see that. In addition to noting when we're working with like terms, we can also combine like terms. And so again, this happens if we know that we have the same variable along with the same exponent for the term. And so once that happens, as mentioned here, it's simply just going to add or subtract the coefficients of the terms. And we always look at what's going on. So we have 3x squared here. We know these are like terms because x is here and here. They are both being squared. So we can think of this as just 8 plus 3 with x squared. 8 and 3 gets us 11. X squared's along for the ride. So we're all done here. If we have 3y and we're taking away y, you could think of this coefficient as an imaginary 1, so 3 minus 1 with y at the end. But think of this as 2y. In addition to that, we have m here, n to the fourth, so we're good to go. We have negative 7, and then we're deducting 5, and we'll leave m, n to the fourth outside. So for this, negative 7 minus 5 gives us negative 12. M, n to the fourth follow this up as well. If you have any questions on this section, please let me know. Please pause the video if you need to go back and look at anything or take notes. Make sure that you're taking notes along the way. I'll check for those in class too.